What if another sun entered our solar system? It began as the faintest smudge of light, barely noticeable in the early evening sky. Most people ignored it, dismissing it as a bright planet or a passing reflection. But night after night, it grew stronger, swelling from a speck to a pinprick, from a pinprick to a shimmering ember. Soon, you could hold up your hand at dusk and see two distinct glows, the familiar golden crown of our sun to the west, and a strange reddish gleam rising in the east. At first, astronomers called it a curiosity. Perhaps it was a comet outgassing unusually brightly, or a nearby supernova whose light had taken centuries to reach us. But when the object's position shifted slightly against the backdrop of distant stars, calculations began to whisper a more unsettling truth. This was no illusion. It wasn't far away. It wasn't passing by. It was entering. And then came the announcement heard across the world. A second star, a small crimson sun, had drifted into the outer reaches of our solar system. Not a fireball screaming through space, but a patient, steady intruder, moving with the slow inevitability of gravity's command. Scientists estimated it was a red dwarf, 1/5 the mass of our sun, yet heavy enough to disturb the cosmic balance that had shaped life for billions of years. The effects, though subtle at first, became impossible to ignore. Nights shortened as the newcomer's dim but persistent light stretched twilight into the small hours. Shadows began to double during the day, the darker one sharp and golden, the other faint and rust-red. Animals grew restless, owls hunting earlier, migratory birds losing their sense of timing, sea turtles emerging to nest under skies that never grew fully dark. Farmers noticed crops sprouting faster in winter months, only to wither under unexpected heat. In cities, people gathered on rooftops, staring in silence or celebration. Some called it a miracle, proof of divine design. Others felt a creeping unease, sensing that nature does not give without taking. For millennia, humanity had lived under a single source of life and warmth. Now, a second sun had arrived, and with it, a question as vast as the heavens themselves. Was this a gift from the cosmos, or the beginning of its reckoning? Before the red dwarf appeared on the edge of our cosmic neighborhood, life on Earth was guided by a precise and ancient rhythm. For billions of years, a single sun had been the heart of this intricate system, its gravitational embrace holding 8 planets, hundreds of moons, and countless asteroids in a stable dance. Earth's orbit was nearly circular, its axial tilt gave us predictable seasons, and every creature, from plankton in the ocean to migrating birds, synchronized their existence to this celestial metronome. By the early 21st century, humanity had grown confident in the permanence of this order. Our science was advanced enough to map the orbits of distant exoplanets, send probes beyond Pluto, and track near-Earth asteroids decades in advance. Artificial intelligence sifted through mountains of astronomical data, flagging anomalies in seconds. Private companies were mining asteroids for rare metals. Mars bases were being built. Telescopes the size of skyscrapers scanned the heavens from deserts and mountaintops. We were explorers, engineers, masters of our own sky, or so we believed. In astrophysics, there was always the quiet awareness that the galaxy was not a static place. Stars were born, drifted, and died. Some were cast adrift entirely, rogue stars wandering between systems for millions of years. The probability of one passing through our solar system was small but never zero. For most, it was the stuff of theoretical papers and speculative documentaries, a conversation starter in astronomy classrooms, not an actual scenario to plan for. And yet, with hindsight, there were signs we missed: slight orbital deviations in long-period comets, an unexplained background glow in infrared surveys, data points dismissed as calibration errors. The solar system, so steady in its grand design, was never truly isolated. It was just waiting for the right moment for the galaxy to remind us of that truth. When the red dwarf finally made itself known, all our technologies, all our achievements, could only confirm the fact. We had not prepared for this. The age of the single sun was ending, and the era of the double dawn was about to begin. The world's first clear encounter with the second sun began in the thin, dry air of the Chilean Andes. At the Paranal Observatory, astronomers noticed something unusual. A bright object, catalogued years earlier as a distant red giant, was not behaving as expected. Its light curve hinted at motion far too rapid for a faraway star. A week of frantic measurements revealed the truth. The object's apparent position was shifting against the fixed stars. That meant it wasn't in the deep background of the galaxy. It was in motion relative to us. And it was heading inward. Within days, parallax readings confirmed the unthinkable. The newcomer was inside the Oort cloud, the icy halo marking the solar system's outer boundary. The math stripped away any doubt. This was a red dwarf star, perhaps 1/5 the mass of the Sun, on a trajectory that would bring it dangerously close to our planetary family. Its speed was not reckless, but inevitable, as if pulled into our domain by some long chain of gravitational encounters across light years. When the official announcement came, it ignited the global imagination. News anchors spoke with barely disguised awe. Social media erupted with speculation. Was this a second source of life-giving warmth, or a cosmic predator? Conspiracy theories flourished. Some claimed governments had known for years. Others insisted it was an alien construct disguised as a star. Religious leaders from dozens of faiths interpreted its arrival as a sign, a warning, or a blessing. But for scientists, awe was tempered with dread. Even a star this small could tug on planetary orbits, stir up comets, and alter the delicate gravitational harmony of the solar system. Already, long-range observatories detected faint irregularities in Saturn's rings. One research station in Hawaii noticed slight deviations in Jupiter's magnetosphere. Deep in Earth's crust, sensitive seismographs picked up tremors from tidal forces so subtle they escaped ordinary notice. Yet for the billions watching with unaided eyes, those warnings felt distant. What they saw was beauty, a second rising light, copper red and mysterious, sharing the heavens with the golden sun they had always known. Humanity stood on the edge of a transformation it could not yet comprehend, gazing at a cosmic neighbor whose intentions were written only in the language of gravity and time. In the months following the red dwarf's public debut, its presence shifted from scientific headline to daily reality. At first, the changes were subtle. A slightly brighter night here, a warmer spring there. But soon, those living in mid-latitude regions began noticing that true darkness had grown rare. The new star's faint crimson glow stretched twilight far past its usual limits, casting ghostly double shadows in every city street. Photographers captured surreal images of parks bathed in gold from one horizon and rust red from the other. Agriculture was among the first sectors to feel the disruption. With an extra source of light, certain crops grew faster, but they also required more water. Farmers in temperate regions reported early harvests followed by unexpected wilting, as temperature patterns no longer matched traditional planting cycles. Nocturnal insects emerged at odd hours, altering pollination rates. In the tropics, coffee plants flowered twice in a single year, confusing both farmers and the markets that relied on predictable yields. Urban life adapted quickly on the surface. Businesses advertised dual sunset dinners, and travel agencies sold 2 suns, 1 vacation packages. Solar energy companies rushed to develop panels that could capture power from both light sources, promising record-breaking efficiency. Yet behind the optimism, scientists issued early warnings. Orbital models showed that even this distant red dwarf was exerting measurable gravitational influence on Earth's path. The effect was minute for now, but over time, it could nudge us closer to or farther from our primary sun, triggering severe climate instability. Governments hesitated to sound alarms. Economic opportunity was too tempting. New light meant more productivity, extended working hours, and expanded growing seasons in cooler regions. For political leaders, it was easier to frame the second sun as a cosmic gift rather than a looming threat. But nature's balance is delicate. In the shifting currents of the atmosphere, in the altered migration patterns of whales, in the quiet, restless movements of tectonic plates, the first signs of deeper change were already in motion. Humanity's celebration was real, but so was the countdown to consequences. As the years passed, the novelty of a twin-lit sky faded, replaced by the slow realization that the red dwarf's presence was no passing phenomenon. Orbital simulations grew increasingly alarming. The gravitational tug-of-war between the two suns began subtly shifting the outer planets. Neptune's once precise orbit now wavered by measurable degrees, while Jupiter's moons showed unusual tidal heating, their surfaces cracking and venting plumes as internal ice melted. On Earth, the impacts deepened. Climate patterns fractured into strange new rhythms. Many regions now experienced two peaks of summer heat each year, separated by odd, lingering, false autumns. Coral reefs, already fragile, suffered bleaching events at double the frequency, unable to recover between assaults. Fisheries collapsed in some regions as migratory species lost their seasonal cues, scattering unpredictably across oceans. Human society reflected these environmental fractures. Some cultures embraced the red dwarf as a spiritual symbol, building new rituals around the twin dawn, and seeing it as proof humanity was not alone in cosmic significance. Others viewed it as an invader, a destroyer of balance, blaming it for droughts, floods, and crop failures. This divide wasn't just philosophical, it drove geopolitical fault lines. In space, competition turned to conflict. The altered orbits of certain asteroids brought rich mineral targets within easier reach of Earth, but these same rocks now drifted unpredictably, crossing claimed mining zones and sparking disputes between corporate fleets and national space programs. Resource skirmishes erupted in orbit, fought not with guns, but with hacking drones and propulsion sabotage. The psychological impact was harder to measure, but impossible to ignore. For all of history, humanity had one sun, a singular source that anchored our sense of time and place in the universe. Now, with two, that sense of uniqueness dissolved. Our solar identity blurred. Were we still the children of our sun, or of a new binary system born from chance? That question lingered in art, philosophy, and politics alike, even as the slow machinery of gravity continued to reshape the world in ways we were only beginning to understand. To understand the upheaval caused by the second sun, we have to imagine the solar system as a vast, delicate clockwork. For billions of years, its gears, planets, moons, asteroids, turned in perfect balance under the gravitational command of a single master, our sun. Every orbit was a finely tuned compromise between speed and pull, with distances and periods locked in a harmony that allowed life to flourish. A red dwarf star, even at only 20% the sun's mass, is no small addition to this equation. Its gravity doesn't simply add to the sun's, it competes with it. Planets feel two centers of pull, their paths subtly twisted into new shapes. In celestial mechanics, this is called a three-body problem, and it's notoriously unstable. Tiny changes can cascade over time into wild orbital shifts, sometimes ejecting smaller bodies entirely. Beyond the planets, the Oort cloud, a distant shell of icy debris, has become a stirred-up snow globe. The red dwarf's approach sends countless comets onto altered paths, some into the void, others inward toward the inner planets. Each new inbound comet is a potential hazard, a frozen missile capable of global catastrophe. The second sun's light, though far dimmer than ours, still matters. Earth's energy balance depends on how much sunlight it absorbs and reflects, its albedo. The red dwarf's reddish spectrum interacts differently with our atmosphere, penetrating haze and cloud layers in ways our sun's light does not. The result? Certain regions, especially deserts and ice fields, warm faster than climate models had predicted. Scientists use supercomputers to model the combined gravitational and radiative effects, but the complexity is staggering. Predicting the precise orbits of every planet decades ahead is now impossible without constant recalibration. For the first time in human history, our species is forced to admit that the solar system itself is a moving target, its rules rewritten not by our technology, but by the slow, relentless physics of two suns pulling at everything we know. The turning point came without the slow grace that had marked the second sun's arrival. It began with weather patterns collapsing in unpredictable ways. Earth's slightly altered orbit, stretched by the gravitational tension between the two stars, threw the seasons out of sync. In some regions, winter storms pummeled the land when crops were just beginning to sprout. In others, searing heat waves struck during what should have been the rainy season. Agricultural schedules, the backbone of human survival, fell into chaos. Food shortages spread like a shadow. Grain reserves dwindled. Nations that had relied on predictable harvest cycles found themselves importing emergency supplies at ruinous costs. Civil unrest flared. Protests filled city squares from New Delhi to Sao Paulo, demanding solutions to a crisis that seemed as much cosmic as political. Then came the asteroids. The red dwarf's tug on the asteroid belt had been quietly increasing for years, turning stable orbits into unstable ones. A chain reaction of high-speed collisions created showers of fragments, many of which hurtled toward the inner planets. Early warning systems lit up with alerts, overwhelming global space agencies. Several impacts were small, harmless in terms of casualties, but terrifying in symbolism. One cratered into the Siberian tundra, another exploded high over the South Pacific in a blinding fireball visible across half a hemisphere. But the true moment of fear came when a 6-kilometer-wide rock missed Earth by only a few 100,000 miles. Astronomers calculated that if its approach had been shifted by just a few hours, the strike would have been extinction level. Markets collapsed. Insurance systems imploded under the strain of unquantifiable risk. Coastal cities, already battered by rising seas from accelerated ice melt, faced evacuations as storms intensified. The narrative shifted from curiosity to survival. The red dwarf was no longer the second dawn. It was the agent of a destabilization no one could fully control. Humanity stood at the edge of a decision: adapt with unprecedented speed, or be swept aside by a cosmic reshuffling that had only just begun. Faced with a crisis that no nation could solve alone, world leaders convened an emergency summit, unlike any in history. They called it the Dual Star Accord, a binding pact that pooled the resources, technology, and intellect of the entire planet. For the first time, military budgets were openly diverted to planetary defense, and rival superpowers shared data streams in real time. The objective was simple in theory, daunting in execution: ensure humanity's survival under the pull of two suns. The most ambitious undertaking was Project Exodus, a dual-pronged plan to secure Earth while preparing for off-world refuge. One branch focused on building colossal orbital habitats capable of supporting millions, supplied by fleets of autonomous mining ships, harvesting the altered asteroid belt. The other branch prepared Mars and the icy moons of Jupiter for large-scale colonization, racing against the destabilizing clock of the solar system. Meanwhile, Earth itself needed saving. Astronomers and engineers proposed an audacious scheme: using gravitational assists from Jupiter and precisely timed nuclear detonations to make micro-adjustments to Earth's orbit, keeping it within the shifting habitable zone. Critics called it insanity. One miscalculation could fling the planet into a slow spiral toward one star or the other. But with climate systems collapsing and asteroid impacts becoming more frequent, there was little choice but to gamble. Society transformed under the pressure. Architecture shifted toward heavily shielded designs to withstand increased radiation. Agriculture moved underground or into massive sealed towers, lit by engineered spectra optimized for crops. Education adapted too. Children now learned celestial mechanics alongside reading and math, because every generation would inherit the task of maintaining Earth's fragile trajectory. In this strange new normal, the sight of two suns no longer inspired only wonder or fear. It became a constant reminder that survival was not a passive state. Humanity was now an active player in the mechanics of its own solar system, and perhaps, for the first time, truly a spacefaring civilization. Decades after the red dwarf's arrival, Earth was no longer the same planet it had once been. The coastlines had shifted, swallowing entire cities into the sea. Some equatorial regions had been abandoned, transformed into sweltering belts of unbroken heat. Yet in the face of upheaval, humanity had adapted, and in some ways, thrived. The skies now carried a permanent dual glow. At midday, two shadows stretched from every object, one sharp and golden, the other faint and rust-colored. Vast orbital arrays encircled the planet, harvesting energy from both stars and beaming it to Earth and off-world colonies. Power shortages were a relic of the past, though this abundance had been bought with decades of sacrifice. Mars had grown into more than a scientific outpost. It was now a bustling frontier city world, its domes glowing against the red dust, home to millions. The cloud cities of Venus floated serenely above toxic storms, serving as research hubs and trade centers. Even the icy moons of Jupiter bore the signs of human life, their underground oceans warmed and lit by nuclear fusion reactors. On Earth, society bore little resemblance to its former self. Nations still existed, but planetary governance was coordinated through the Dual Star Council, ensuring orbital adjustments and asteroid defense were managed collectively. Cultural identities had blended through necessity, and education revolved around survival in a binary star system. Children grew up knowing orbital mechanics the way their ancestors had once learned farming seasons. Still, the scars remained. Vast stretches of land were uninhabitable. Entire species had been lost. The human population was smaller, tempered by centuries of crisis. But for those who walked under the twin suns, the world felt both fragile and enduring, a living testament to adaptation. The solar system was now a binary star system, and humanity, forged in the crucible of cosmic upheaval, was no longer a child of a single sun. We were heirs to two. The arrival of the second sun was, at first, a spectacle, then a disruption, then a threat, and finally, a catalyst. It forced humanity to confront a truth we had long ignored. The universe is not a silent backdrop to our lives, but an active, shifting landscape where change is inevitable and survival is never guaranteed. For billions of years, we believed our solar system to be stable, a sanctuary insulated from the restless motions of the galaxy. The red dwarf shattered that illusion. It showed us how fragile our cosmic balance truly was, and how quickly it could be rewritten. The comfort of the single sun had lulled us into thinking permanence was our birthright. The second sun taught us otherwise. Yet in that upheaval, we found strength we didn't know we had. We reimagined our cities, reshaped our agriculture, and extended our reach across worlds. We learned to think in centuries instead of years, to see planetary engineering not as science fiction, but as a necessity. And perhaps most importantly, we learned that survival is not simply about enduring change. It is about mastering it. The price was steep, lives were lost, landscapes altered beyond recognition, and entire cultures reshaped under the weight of adaptation. But what emerged was a civilization more resilient, more united in purpose than any that had come before. Our species had stepped from being the children of a single star to the stewards of a binary system. Now, each dawn brings two lights to the horizon, a reminder of what was and what is. The golden sun, ancient and familiar, still warms our oceans. The red dwarf, once an intruder, now shares the sky, a constant symbol of both danger and possibility. And so we ask ourselves, if another wandering star were to appear on the edge of our vision tomorrow, would we fear it, or would we be ready to welcome the challenge it brings? The answer, like the twin shadows we cast, may always be a reflection of both our caution and our courage. If the universe has taught us anything, it's that nothing stays the same forever. Worlds shift, stars wander, and the sky we know today may not be the one we see tomorrow. The story of our second sun isn't just about survival, it's about who we became when the rules of our reality changed. So, As you watch the horizon fade into gold and crimson, ask yourself, what would you do if the cosmos knocked on our door again? Would you run, resist, or rise? If this journey through the double dawn made you think differently about our place in the universe, share it with someone who dreams big, and let's talk in the comments, because in a galaxy full of moving stars, our next story may already be on its way.